So I'm going to do the quick poll again. Just the first letter, A, B, C, D, E, F. Okay, what do you need to know to do this?
Displacement?
Okay, what about displacement?
The definition again?
Okay, give it to me.
The final minus the initial?
Okay,
Or
all right, yeah, it's a change in position
yeah, direct.
Total not a minute.
with direction.
Yeah.
Okay, do you guys agree with what they managed to spit out? Final minus initial with direction? All right, it was a joint effort, but it was a good one. Yeah, that's our definition of displacement. So let's go ahead and let's say what is happening with this one with regards to displacement. What's the displacement on A? Why? How do you know it didn't move anywhere? What? Rest, right? Okay. What part of the graph are we looking at to get this information?
The 10 seconds.
No.
The position, right? Because it's about displacement. Displacement's really just the change in position with an arrow, which means that is our vertical. Okay, so this one has a delta x, our displacement of 0. Okay? B. What do we got?
At rest, zero?
It's at rest, therefore, okay. C. 10. Okay, not 1? So we just want the y-axis, right? All you want's the y. We don't care what happens over time. We care that it goes from 0 to 10. So basically, if you're looking for position, this is the part you're looking for. Okay, what's this one? D? 3. Okay. Remember, delta x is a change in position from final, well, the vector goes from initial to final. The change in position is always, math-wise, final minus initial. So that's 5 minus 2 is equal to 3 meters. Next one, what do we got? What's this one?
Oh, yeah.
Yeah, is that negative?
That's-
Negative 30?
Negative 30. Let's do the math. Because if it's final minus initial, my final position is where it ends. So my final position is 0, and my initial position is 10. 30, 30, which gives us negative 30 meters.
Is that still greater than 10 meters?
What did it say at the top of the paper?
No, 0 is greater than negative. How is it possible?
0 is greater than negative.
So that means it's less.
Yes. Okay. Now what about,
But
go
I
ahead.
thought it didn't matter which way you went. It just mattered how far you moved.
What is that quantity? That's not displacement.
Yes, sir.
That was displacement, just as long as you're moving away from 0.
Distance?
If it doesn't matter which way you go, it's distance. If it matters which way you're going, that's displacement. Okay? All right, and our F. What is this one?
Oh, yeah.
0.
Why is it 0, Joe?
So like final minus initial. So like you start at 0, but then you end at 0.
Yeah, you start and end at 0, right? Okay. So would this be a different set of answers if the question was the distance that you traveled or the path? All right. All right. In this particular case, especially on F, the distance is still 0, isn't it? According to our definition, it's basically still the final minus initial. It's just no direction. But that would be if it was. What would it be if it was the path traveled?
16.
16. Okay, so let's put our answers in, and we should end up with what? C, D, A equals B equals F, and then finally E. All right. Who got it right? All right.
I just misplaced the E. Yeah. The E was.
D in the
Yeah.
front.
Okay, no, there's tricky ones in there. Okay, so next up, we're going to look at the one on the back. However, and I'm going to talk to you about some changes and how people have talked about things. Now, displacement is the vector change in position from final to initial. It's final to initial with direction. And the correct definition that you got for distance is that it is your change in position, but just the magnitude, right? It's the magnitude of your displacement. And your path traveled is your total distance. That is a different phrasing from what they used to use. Okay, and by used to use, I mean last year. Okay? Previously, and you just have to keep your eyes out for this, that a lot of times they will talk about distance and path traveled similarly. Okay? So, for this particular problem, when you're doing the speed side, what does your definition of speed say in your notes? The one that you looked it up. So definition of speed in your notes. It's also not Lightning McQueen.
That's in the flash.
I know, but speed
Oh, yeah.
is Lightning McQueen. All right. What's our definition of speed? You have average and you have instantaneous. We have not talked about it beyond what you did as your definitions. But tell me what the definition is. Valerie, do you have yours out? All right. First off, just so you know, I do tend to record some of this stuff. It had timed out, so if anybody ever listens to this and they wonder why there was this weird jump, I have no clue where it stopped during our discussion of distance. So, and I'm not going to go back and fix it. So I'm saying this for whoever's listening.
What happened though?
It paused in the middle of the conversation.
Oh, that's
it timed out.
I think that's because you timed out.
Yeah, it just timed
Oh,
out.
yeah.
Okay, so we're doing speed now. So we've already talked about what it is. It's basically distance and time, right? Or distance as the total path length divided by the time. What else is important for you to know if you're talking about speed as compared to velocity? Direction. Which one has direction?
It's being
Well, displacement has direction, right? All right. And again, like we're extending a little bit past. You had speed and velocity. You wrote those definitions. Which one has direction? Velocity, right? Here's a little trick. Speed, scalar. Velocity, vector. Okay, just a small thing. Okay, so what is the speed for A?
0 meters per second.
It's 0 meters per second, right? Because it hasn't gone anywhere.
You're just standing
Okay, which also means that the speed for B, same logic, is right here. All right, what's our speed for C? Yep, if speed is essentially the total path divided by the time, it is 10 divided by 10, 1 meter per second. Now, the next one is going to be, all right, 3/10 or 0.3 meters per second. Now,
Rather have a fraction or a decimal.
in general, decimals, for this type of quick thing, I might leave a fraction up because we're really not doing much with it beyond acknowledging it. Okay? What about speed for B?
B or E.
Don't you mean
E, yes.
3 meters per second.
All right, 3 or negative 3? Why?
Negative 3 because it's going down.
Okay, so yes, it is going down. Now, the question is this a speed problem or a velocity problem?
Speed.
Does speed have direction or not?
No.
No direction, so then do we care about it?
So it'd still be 3.
Oh my god.
So we're gonna, huh?
So it'd still be 3.
It's just plain old 3. Did you look into that one?
No.
Okay. This is a scalar, so we don't care about the direction. The fact that it's going back towards the origin doesn't matter. All right, here's a fun one. F.
1.6 meters.
Why is it 1.6?
Because you're going 8.
Your
Because
distance
it's
traveled is
16.
Oh, yeah.
16.
And then your
And
time
then
is 10
it's
seconds.
in seconds.
Yeah.
Yeah, 8 up, 8 down is a total of 16, giving us 16 divided by 10, or 1.6 meters per second. Or what? 8? I don't
I
know.
got 1.6, but I totally forgot how I did that.
Probably just the way we said it, 'cause I'm not sure how else you could get that.
I don't know.
All right, because it goes 8 up, it goes 8 back. And there we go. So let's put our answer down. So the first one was for the displacement. This one is for our speed side. Our biggest answer then was E, followed by F,
C,
C, D,
A, B.
C, D, A equals B, right? Okay. All right, so what are we going to do with this? All right, yes. What's the part you haven't done on this page yet? The reasoning. Now let's talk about how that reasoning pertains. Throughout AP Physics, the redesign, one of the big things they've got is that they realized that a lot of people could plug numbers into a calculator really well, but they couldn't actually talk about physics to save their life. All right? So with the new redesign, that's one of the things we're really working on. If you look up here at this sign, it says claim, evidence, and reasoning. Any explanation that we do where I ask you to explain your reasoning, it's just these three things and go in with it. If you'll notice my underlines, CL, EV, R. Put it all together and it spells badly clever. Yeah, well, hey, if we can make a bad mnemonic out of it, we will. All right, it's a nice little cheesy thing. So claim is your answer. Evidence is the physics or the facts or the data behind it, the hard stuff. And then your reasoning is how your facts apply to your answer. All right? Your homework with regards to this is to give me claim, evidence, and reasoning for these two problems. Do you now have all the information you need to do that correctly for this? Whether or not you will, we're going to see how that works out. But you have all of this. It's in Google Classroom. You're going to do it in Google Classroom. You're going to submit it through there. Claim, evidence, reasoning. Exactly what we said. You have your answer already. We've discussed lots of the evidence. Maybe you'll have something else. Reasoning, your ability to tie it back. Do not write a lot. Okay, this is not English class. This is not history class. I don't care about your ability to use big words unless it's scalar or vector. All right? Short, to the point. You can even bullet point some of this stuff if you wanted to. All right? The point on this is your ability to speak quickly and clearly and get those ideas across. All right? I think the only other thing on the directions, other than write, claim, evidence, response, you only need 2 to 3 sentences or bullet points. And I ask you to write your claim like in red, your evidence in blue, and your reasoning in green. Okay? I want you to be aware of what you're putting in there. I'm done talking about that. The other thing to talk about briefly is your lab. It's due on Monday, not tomorrow, if you hadn't heard that yet. Okay? So we have whatever time is left in class to work on it today. And most of you should get it pretty much done. Anything else will have to happen after school. Do not wreck yourself doing those velocity graphs, guys. All right? If you know how you're supposed to be walking, and you get kind of vaguely-ish, all right, I'll accept it if your description actually matches how you describe it. But is the velocity the same thing as this position graphs? No. Is it pain in the butt, actually? All right, because you're having to think about it, right? You're looking at different things. So don't just say, and move on. I know how to describe it. Talk with me, talk with your team. Make sure you know how to describe it. Okay? I'm done.